welcome back. Thanks for checking in. As you can see, we are moving on to day 2 of this multi-step equations and inequalities lesson. In your textbook, we're still at lesson 5.5. If you care to follow along, that's chapter 5, lesson 5 on page 248. First of all, let me congratulate you on finally making it to the end of Unit 2 in our math curriculum. This whole unit has been about equations and expressions, and at the very end here we've also been talking about inequalities. You've certainly learned to do a lot in this unit, and I'm extremely proud of how far you've come. So let's finish it up with a bang, shall we? We're going to be seeing multi-step equations today, and maybe some inequality symbols in there as well, but you know, all in all, we basically work with those equations and inequalities the same way. What we're looking at today are some types of equations and inequalities that are called special cases. And what you're going to see as we work through these 4 examples is that sometimes the answers to an equation or an inequality aren't exactly the kinds of answers that we're so used to seeing, where x is equal to 2 or y is greater than or equal to -7. We're going to see some examples today where sometimes there really aren't answers to equations. And sometimes there are so many answers to equations that we cannot even list them all. So these are called special cases, all right? So we're going to start off here with our first definition, which is called null set, N-U-L-L, that's null, and it also is referred to sometimes as empty set. Null set or empty set is when an equation does not have an actual solution, meaning that there is no value for the variable that makes the equation equal on both sides. So it's when you end up with a 0 attached to your variable, such as the example here that you see in red, where it says 0m equals 20. Now, just for a minute, think about what that's saying. 0m means 0 times m. How could 0 times any number ever be equal to 20? It absolutely could not ever, because 0 times every number is always 0. So when you end up solving an equation and you get down to a situation like this, that 0 is attached to your variable, that means 0 is your coefficient, that is definitely no solution. There's no number that you can plug in for m that you're going to multiply by 0 and have an answer of 20. So that's called null set or empty set, or sometimes we even call it no solution. So we're going to be seeing some of those today. Now on the other hand, we have the opposite thing that happens sometimes. And the opposite things is called identity, or all real numbers. And that is when an equation has an endless number of solutions, meaning any number you plug in for m, or for any variable, any number that you can think of is going to work in the equation. So it's when you notice that both sides are identical to each other, as you'll see in this example here in red. If you notice that the left side says 8m minus 2 equals 8m minus 2. When you see that the left side and the right side are identical to each other, they have the same variable term and they have the same constants, that is called identity, or all real numbers, because you can plug in any number for m and it will work. I'll prove it to you. Let's say m has a value of 1. Okay? Let's make it 1. Let's make it 1. 8 times m is 8 minus 2. Over here, 8 times 1 is 8 minus 2. On the left, 8 minus 2 is 6. On the right, 8 minus 2 is 6. And 6 does equal 6. It's balanced. It works. Okay, let's change the value of m. Pick another number. What? I don't want that on my screen. Go away. What? settle down. Let's pick another value. Let's make m have a value of 2. All right, watch, I'll show you. 8 times 2 is 16. 8 times 2 over here is 16. 16 minus 2 is 14. 16 minus 2 is 14. 14 does equal 14. See what I mean? This is an example where no matter what number I choose for m, I'm going to end up with the same answer on both sides. That's because the left side and the right side are identical, and it's called identity, meaning all real numbers will work for the value of your variable. So again, we have some cases where no number will work. That's called no solution or empty set or null set. Or we have situations where any number you choose will work, and that's called identity or all real numbers. So let's take a look at some of these special cases. And of course, they are multi-step equations. So right away, I see that I'm going to be distributing the 3. So I'm going to have 3y and minus 15. Then there's my plus 25 equals 3y plus 10. Okay, I like that right there. Looking at the left side, I notice that I have a minus 15 and a plus 25 that I can put together. They're on the same side of the equation, so I'm just going to combine these two pieces. And negative 15 plus 25 gives me plus 10. And I'm going to bring down my 3y, and I'm going to rewrite everything else that I have on the right side of the equation. And lo and behold, do you see anything? I do. I see on the left I have 3y plus 10, and I see that on the right I have 3y plus 10. They are identical. When it's identical on the left and the right, you don't even have to go any further because this is officially the identity property. Because any number I choose to plug in for y here and here, I'm going to be getting the same answer on both sides. Whether I choose a 0 or a 1 or a 10 or 1,000 or a negative 20 for y, it doesn't matter. I'm always going to get the same answer on both sides. You could call that identity, or you could call it all real numbers, because any number you choose will work. Let's take a look at this guy. There it is. On the right-hand side, I see some distributive property. Let's distribute that 2. That gives me 4s and plus 6, and then there's my minus 9s. On the left, nothing has changed. So I'm looking at the right-hand side, and I see that I have 2 constants that can go together, a positive, oops. I circled the wrong thing. I don't have 2 constants that can go together. No. I have 2 variable terms that can go together. I have a 4s and a minus 9s. 4 minus 9 gives negative 5s. There's my plus 6. And over here I have negative 5s, and that's a minus 14. Let's see, I need to deal with my constants first. I'm going to add 14 to both sides. Remember this? These multi-step equations, we try to focus on our constants first. Plus 6 plus 14 gives me plus 20. Now I need to move that minus 5s over to the other side. So I'm going to add 5s. So that cancels, and add 5s there. I get 0s equals 20. Now stop and think about that. 0 times s equals 20. There is no number that if I multiply by 0, I'm going to get a 20. This is null set or empty set, or I would even allow you to say no solution. No number will work right there for s. If I multiply by 0, that would result in a 20. Let's try 2 more, and then we'll be done. Oh, holy cow, look at all this distributive property here. Let's distribute that -2. 1r. Okay, I look at the left side, nothing to do on the left. I look at the right side, I have a -5r right here. That can be combined with this -1r. Let's just put our like terms together. That gives me -6r minus 8 on the right. And on the left, -6r minus 8. Do you notice anything? I do. I think they are identical. Identity. Same exact thing on both sides of the equation, so you can stop there. Last one. More distributive property. 4 times 8, 32. 4 times plus 2w is positive 8w. I look to see if they look identical, and no, they don't. So let's keep moving. Let's keep working forward. I think I'm going to subtract 14 from both sides. Bring down my 8w on the left. 32 minus 14 is 18. Now that plus 8w on the right needs to move over to the left, so I'm going to subtract 8w. It cancels off on the right. That's the one that I moved away. 8w minus 8w is 0w's. And what do you think? 0 times w equals 18. 0 times nothing is ever going to result in 18. So this is null set, empty set, no solution. So again, let me review. These are special cases, and they don't happen very often. Sometimes in equations you have no solutions, and sometimes in equations you have all real numbers as your solution. So as you can see, we're not going to be doing very many problems in class. These are going to be special cases. And it looks like we're going to be doing a little bit of graphing on the last few problems on a number line. So we must be working with some inequalities during class, even though we didn't have any inequalities in this specific video, all right? So thanks for watching, and congratulations on making it to the end of your second math unit. We'll be looking at having an assessment pretty soon. I'll see you in class.